course of the day. If you look at this example right here, you can see, like this is the framing of the house, the wall and the ceiling is right there. And then doesn't this represent the roof right here, the angled part? Can you see the little shingles in there? Kind of like on top. No, can you see them? They're like right there, the little shingles that are on top of the roof. Yeah. And so then, does anybody know what tool this is right here?
It's a level.
It's a level, right? It's a level. So a level has like a little bubble in liquid, and as the level is tilted at an angle, the bubble will shoot off to the side. But as you bring that level closer to actually a level angle, right, a horizontal angle, the bubble will settle right in the middle of the little window, and you'll know that tool is actually horizontal. And so, according to this, the level is 1 foot long, and this is 7 inches as far as that height goes. So, just in this little example here with the level and the roof and everything, what would you guys guess the pitch of the roof is? What would you think?
Like the grade.
Yeah, it is, but specifically for this one, which numbers? What would you say?
7/12.
You've got to be careful with this, right? Because it's 1 foot, but hold on. It's 1 foot and 7 inches. So aren't the units a little messed up?
So it's 7/12.
Yeah, I'd say 7/12, right? So 1 foot is really 12 inches. So I'd say the pitch there is 7/12. It's a 7/12 pitch. So if you guys could kind of try to take that principle with number 6 right there. It's not as sophisticated of a drawing. It's just a little red triangle, I guess. But if you could try to find the pitch of that roof, let's see what we do with this. Using slope to find the pitch of a roof.
When you said pitch,
I'm sure you're right. Okay, Christiana, what did you come up with for the pitch of the roof on number 6?
I got 2.5/12.
Where did you get 2.5 from?
That is what I got. Or just kidding. That's our 5/12. Sorry.
5/12. So are you more sure about 5/12?
Yeah.
Okay. So she says 5/12 pitch for number 6. What do you think? Is that correct? What's the little trick? You are correct. What is the little trick on number 6? What do you see, Evan? It gives you 2 sides to the roof, right? You do have to split the 24. Yeah, so 5 is definitely the rise, but the run is not 24. The run is only half of that 24. The run would have to be 12. So yeah, well said, Evan. Okay, any questions? 2 applications down, 1 to go. The first one was grade, right? Like the percent grade of a road. The second one was this roof pitch. And the final one is going to be rates of change. So flip on over to that one. Change, like whenever you see the word rate or rates of change, something along those lines, that almost always means slope. Almost always means slope. So rate of change or rate, you can almost always interpret that as some kind of a slope of a graph. So let's read this one here real quick. It says, a bank offers a business account with a fixed monthly fee plus a service charge for each check written. The relationship between the monthly cost Y and the number X of checks written is graphed below. At what rate does the monthly cost change? So, there's a lot of information given here about what is X, what is Y, and somebody's got a bank account, and on and on and on. But you look at the last sentence. Doesn't the last sentence tell you what you're supposed to do?
Yes. Yeah.
At what rate does the monthly cost change? What is a key word that you see in that final sentence that maybe gives us a hint about what we're looking for?
Rate.
The word rate. It's right there. So anytime you're asked to find the rate of change of this, the rate of change of that, that's another way of them saying, look on the graph and find.
Rate.
Rate means slope of a graph. Yeah, so rate almost always means slope of a graph. So, if you want to, I think this would be a wise move, to circle that word rate and say, hey, this really means that I'm looking for slope. Maybe even you write the word slope as just a reminder to yourself that that's what you need to be doing. All right, so take a look at the graph now. The x-axis is number of checks written, and the y-axis is monthly cost of the checking account. And so they're wanting us to find the slope of this graph, the slope. So how do I find the slope of a line like this? What could I use? Rise over run. I agree with you there. So they were nice enough to give us a couple of points that are on the line, weren't they? So I think I'm going to try to calculate my rise and my run from that. So I would say my rise between those 2 points would be that, wouldn't it?
Yeah.
And then,
Yeah, like y2 minus y1.
oh, I was going to ask if there was another way, and that is another way, isn't it?
That takes a long time.
You know, that's a question of opinion, I suppose, but it probably is a
But,
valid.
like, that one's easier for this problem,
I
right?
agree, I think you're probably right. Okay, so based on that, what is, and by the way, Hunter, if you're wanting to do the y2 minus y1 thing, you'll get plenty of chances to do that today.
Okay.
Don't worry. Okay, so what is the rise on our little triangle there? What do you see, Christiana?
2,
No.
the rise,
The rise is something other than 2.
is it
Is it?
1?
No.
50?
What do you see, Danny?
Is it 4?
It is 4. Each, remember, look over here at your scaling.
Oh.
Each one of those little boxes stands for 2. So you look on the rise right here, aren't there 2 boxes? So the rise really is 4. I want to be really careful with the scale on the graph. Okay, and then the run. Of course, on the run, the scale is different, isn't it? What do you all see for a run? What?
I see 10.
It is by tens, so what's the run?
1 over 5. Oh, wait, no, never mind.
No.
That's not right.
20.
4 over 10. 50.
12 or 50.
50 is the run.
Yeah.
Yes, I heard all kinds of stuff there. Just the run is 50, right? Okay, so if the rise is 4 and the run is 50, you guys said rise over run, and so I would say that our slope is 4 50ths. Of course, that's reducible, so you might want to reduce that.
225.
2/25ths. Question for you. What units would go with this?
We need percent.
Say again?
Don't we need percent?
No percent here.
Oh, I turned it.
135.
Dollars.
Percent.
Monthly cost be measured in dollars, right? There's more to it than just that.
2/5.
No percents. Yeah, so this is not a grade. We're not talking about like a road that somebody's driving up. So I don't know that percent makes the most sense. Obviously, if this was a road and we were looking for a grade, yeah, percent would be a logical unit if we converted it over to that. But
Or decimal.
say again?
A decimal.
We could do a decimal, yeah, but I'm looking for units. So far, somebody has said dollars, and I think dollars partially makes
Dollars
sense.
per month.
Per check.
Per check. Per check. There you go. That is correct. Let's talk about why. So I'll just put dollars per check. How did you get that? Who said per check? Evan said per check. Where did you come up with that?
Because that's what it says in the problem. It says for each check.
Yeah. It does say that in the problem. Doesn't it say something like that on the graph as well? Check out the graph. Did you all notice that the x-axis is in number of checks? And then the y-axis is in dollars? And so when you look at the rise, wouldn't the rise be measured on the y-axis? So it'd be measured in dollars. The run is measured on the x-axis, so it'd be based on the number of checks. So 2/25 dollars per check. So is a decimal, what is that, 8 cents? 0.08, right? 8 cents per check. Seems kind of expensive, but that's just my opinion. Okay, so what do you guys think? Let's just review really quick. 3 applications of slope. Grade of a road, and what are the units for grade of a road?
Percent.
That's a percent. There you go. Roof pitch, right? We didn't really look at units there. There really aren't units there. And then rates of change means slope of a graph. That was our 3rd application of slope. We're going to move on after this. Ben, your hand was up first.
So, do you always use the x-axis for what you need to do?
So I used the y and the x, didn't I? Dollars per check. It should always be y-axis over x-axis as far as those units for slope go. Yeah. Rocky, your question?
I answered it.
Awesome. Okay. Anybody else with a question? Okay. Awesome. Very good. Let's move on to our final topic. A little bit of review. So if you guys would, this first example says graph those two lines on the same coordinate axes there. So you have an opportunity to do this in a couple of different ways. We have learned how to plot a table of solutions. So you could do a couple of input-outputs for these two lines and create the line graph. You could also do intercepts, right? We've worked on those for sure. So you could be doing intercepts to graph both of these. And for those of you that already know slope-intercept form, which we haven't quite gotten to yet, you could use that as well. So take just a couple of minutes here. Let's try to graph both of these lines, and then we'll talk about what it all means. Review, but let's make sure we're good. I'll graph. Hopefully this will be a good review for you. I'll graph these two lines, and I'll graph them with two different methods. So the first line right here, I will graph by creating a table of solutions. Fair enough? Okay, so for that line, I am going to go with X and Y. If I'm going to create a table of solutions, what's almost always a great input? Zero. Zero, I think, is great. I think -1 is okay too, but I think 0 is probably. Don't you think 0 is the best? Because doesn't 0 usually makes things go away, makes things simpler?
We were doing 3, so I was gonna say -1, 0, 1.
Oh, no, we're just going to do 2. But -1, 0, 1, those are logical ones too. So if I plug a 0 into the input on that particular equation, what's my output?
4.
Right, 0 plus 4? Yeah, so that's over with pretty quick. So 0, 4. And then, 1 would be a perfectly good point for X to plug in, perfectly good number. But what would be maybe an even easier number? We already did 0. I don't think, no? 3. What's so smart about 3?
That it goes away.
Won't it cancel out the fraction? I think 3 is a really smart number. So if I plug in a 3, I get y equals -2/3 times 3 plus 4. So wouldn't the 3 and the 3 cancel out? -2 plus 4. I'm coming up with 2. Isn't that handy? I think that's a really smart way to go. So let's see here. My points are 0, 4 and 3, 2. So 0, 4 is 1, 2, 3, 4 right about here. And the other one was 3, 2. So 1, 2, 3, and 2. So I'm coming up with those 2 points right there. We connect them with a, oops, why did that just happen? Let's try that again. 1, 2, 3, 4. I must have accidentally hit the erase. There we go. So you connect those with a somewhat straight line, and there you go. Yep, I erased everything on that last little go around. I don't know how that happened, but whatever. Okay, so there's the line. That makes sense?
That's what mine looks like.
Wait,
Awesome.
when you did this, could they hear your voice?
Yeah,
Can they
they
hear
just heard your voice and your voice too.
Oh god.
Oh, no. Okay.
Where did we find these?
It's on YouTube. They're on my YouTube channel.
Oh my god, we need to go watch them.
You got to go watch them. Okay, so then the other one, y equals -2/3 x minus 1. I'm going to go ahead and do intercepts for this one. So for this one here, if I want to find my x-intercept, let's remember this. To find an x-intercept, you plug a 0 in for y. That's correct. So I'm going to go 0 equals -2/3 x minus 1. And now I've got to solve for x to actually find my x-intercept. So I'm going to add 1 to both sides. So that gives me 1 equals -2/3 x. And then how do I get rid of -2/3? I don't, well, isn't -2/3 times x?
Multiply by.
So I could divide by -2/3, or I could multiply by the reciprocal. That makes sense?
Yeah.
Okay. So if I multiply by the reciprocal, to me, that's maybe the somewhat faster way. I end up with -3/2 is equal to x. I'm kind of skipping a few steps here. I'm going to start doing that a little bit from time to time. Some of you are probably relieved about that, but if it doesn't make sense, let me know. Okay, so -3/2 is my x-intercept, so that would be -1.5, which is roughly right there. And then I think we're going to find the y-intercept to be a bit easier. To find the y-intercept, I plug a 0 in for x. Yep. Things you want to know. Handy facts. So -2/3 times 0 minus 1. Anything times 0 is 0. So my y-intercept is -1. So -1 for a y-intercept is roughly there. So if I connect those 2 points with a somewhat straight line, What appears to be going on here with these two lines?
They're perpendicular.
Not perpendicular.
They're parallel.
They're parallel, right? So if you make parallel lines with your arms, doesn't it look like a touchdown or something, right? So parallel lines never do what?
Cross.
They never cross. They never intersect. What did you notice? What do you notice about those parallel lines as far as their slope? Christiana, what do you think?
Wait, so I have a question.
Oh, yes, go ahead.
So I did not do any of the tables or anything like that.
Did you do slope intercept?
Yeah, I just graphed it. Like I did how that's the y-intercept, right?
Mm-hmm.
So I just put that on the graph and then I did the slope.
So you did slope intercept form.
Oh.
Yeah, you did slope intercept form. So, like I said, if you already remember slope intercept form from before, it was okay to do that here because I didn't say use this method. But please make sure you know how to do the intercept method. Make sure you know how to make a table of solutions because it's very conceivable on a quiz or a test I might say, find the x and y intercept of this line. And you can't say, oh, well, I always just use slope intercept.
Well,
Like, I don't really care about slope intercept. I just want to see the x-intercepts.
I can find the y-intercept.
Oh, yeah, for sure. Yeah. But you see my point, right? I want you to be flexible enough to do any method, but your method is fine. We just haven't officially covered it in this class, so I don't want to use it and be like, assuming that you know it.
Oh, okay.
So, Ben, your question or your answer to that? Yeah, what do you notice about the slopes?
They have the same slope.
They do have the same slope. Parallel lines have the same slope. So if you look lower on your paper there, I think it says on your notes packet, it says something along the lines of parallel lines have some kind of slope. It would be the same slope or equal slopes. Okay, let's go through this next one just a little. Okay, so I'll try to graph these here as quickly as we can. Maybe I'll do intercepts on these. I think that's a pretty quick and easy way. So if I'm going to do this red line, the y-intercept would be y equals negative 3/5 times 0 plus 2. So I'm getting a y-intercept of 2. So right about here. And then my x-intercept is going to be a little bit different. It's going to be 0 equals negative 3/5 x plus 2. If I solve for x, what am I going to get? I'm going to get 10/3, I think. So I'll just put x equals 10/3. Is that right? Yeah, that's right. Okay, so 10/3 is a little bit more than 3. So for that first line, did you get something like this? Yeah? Okay. So for the other line, let's see, I'll do this in gray. I think we'll find out pretty quickly that the y-intercept is 1. Y equals 5/3 times 0 plus 1. So I'm getting a y-intercept of 1. So right about here. Gray might not have been the best color. Okay, and then an x-intercept. It's going to be 0 equals 5/3 x plus 1. So negative 1 equals 5/3 x. I'll be getting negative 3/5 for an x-intercept. So that is over here. And that's between 0 and negative 1. So right about there, I'm seeing that 90-degree angle showing up too. Does yours look something like that?
Yeah.
No? Yes? Yes? Okay, good. All right, so do you see how those two lines, as we said before, appear to form a right angle? A bunch of them, actually, right? 4 right angles, you could say. And so these lines are not parallel because they intersect. We would call these lines perpendicular, is the terminology we're after there. So perpendicular lines. So let's go back real quick. Parallel lines, we said they have equal slopes. Perpendicular lines don't have equal slopes, do they? Does anybody know the relationship between the slopes of perpendicular lines? Close. They are opposite, but there's one more word I'd use to describe them. Yes, if you put those two together, we got it. So the slopes of perpendicular lines are opposite reciprocals. Let's take a look at what those two words mean real quick. We've seen them both. We've never really put them together before, though. What does opposite mean? What is that addressing? Negative or positive, right? The positivity or negativity of a number. And then reciprocal is referring to what?
Like if you flip a fraction.
A fraction gets flipped, right? So take a look here. We're going to soon learn that the slopes are right here. Take a look at those two numbers. Negative 3/5 and 5/3. Do you see how they are reciprocals of each other? And their signs are different? They are opposite reciprocals, guaranteeing that these two lines will be perpendicular. That make sense? Okay, so our final task today is we're going to get a chance to practice the slope formula a bit. So flip over to that last page. A couple of questions there for us to examine. Find the slope of a line that's perpendicular to the line that passes through those points. And we could graph those points if we want, but if we stop and think about it, the slope of perpendicular lines, how are they related again? Perpendicular lines have opposite reciprocals. So if I could find the slope between those 2 points, then I could then pretty easily find the slope of the line that I want, the perpendicular line. How do we find the slope between 2 points? What do you use?
y1 or y2 minus y1 over x2 minus x1.
That's right. So I'll just write that. You guys remember which letter represents slope usually? M. So I'm going to say M equals exactly what Christiana said, y2 minus y1 over x2 minus x1. So a chance to practice this. If we were going to do this, Hunter, what would you choose to be your y2? Okay, 7 makes sense. So if Hunter chose 7 to be his y2, what would have to be the y1? It would have to be 4. That's right. And since 7 is his y2, what would have to be the x2? 5. Is this making sense? The x's and y's going together here. So 5 is x2, leaving x1 to be -3. Yep. So minus -3. Be really careful with that denominator. It's not 5 minus 3. It's 5 minus -3. Which changes things. So, of course, that's 5 plus 3, really. So what are you guys coming up with for a slope of that line? 3/8 makes sense. So that's the slope of the line that connects those 2 points. So what they've asked us to do, what this question has asked to do, is find the slope of the line that's perpendicular to that one. So the slope that I want, I'm going to put perpendicular slope. What do I do with that 3/8?
Opposite reciprocal.
Opposite reciprocal. So flip it and change the sign, right? So instead of positive, it's negative. We end up with -8/3 for our perpendicular slope. Does that make sense? That does. Okay, so the final one there is number 9. Number 9 is kind of a chance for you to investigate. It says, determine whether the line that passes through the points 1, 4, and 5, -2, and the other line that passes through 6, 2, and 9, 7. We've got 2 lines here. Determine whether these lines are parallel, perpendicular, or neither. Take a minute, investigate. You're going to have to be working with slope to figure this out. Give it a try. Sam, can you tell me, did you figure out the slope of this first line?
Yes.
Okay, let's hear what you did. M equals,
y2 minus y1 y2 minus x1.
okay, so what was your y2?
-2.
Minus, what was your y1?
4.
Awesome. X2 in the bottom is?
5.
Minus 1, good. So she's perfectly executed y2 minus y1 over x2 minus x1. Now we just need to simplify it a little bit. So what did you come up with?
-6 over 4.
Very good. Did you reduce that by any chance?
I did not.
How would that reduce? You don't really have to do that, but
-3 over 2.
yep. Okay, so the first line has a slope of -3 over 2. So we'll just kind of hold off on that for a moment, and we'll try to figure out what's going on with the other line. So Alec, did you figure out the slope on the other line? Let's hear what your steps look like. I just want to, how did you set up your y2 minus y1 over x2 minus x1? Okay. Very good. And so you said 5 over 3? Okay. Did you all get the same thing? Okay. So now, to determine whether these lines are parallel, perpendicular, or neither, I need to compare those slopes. Are they the same slope?
No.
Obviously not. Are they opposite reciprocals?
No.
They do have opposite signs, right? But they're not reciprocals because of the 5, right? And so since they are not the same slope, they're not parallel. Since the slopes are not since they're not opposite reciprocal, they're not perpendicular either. And so this would actually be a neither. None of the above, right? It's not parallel. They're not parallel. They're not perpendicular. So that's just it. Yes, sir.
On his, do we have to write down the whole formula, or can we just write it down
Oh, like you have to do this part?
Yeah, I just did all that in my head. I just looked at the points and then just said,